we are going to begin the hands-on session on K omega, and this session will be conducted by Mr. Abhushan once again. So Abhushan, if you are ready, we can start.
Okay, let's start the next hands-on session using spoken tutorial. So till now, I think you have done the hands-on session on pipe flow simulation. This is added on top of it. Now you'll simulate the same pipe flow, but you'll add turbulence modeling on it. So I'm providing link for that spoken tutorial in the chat. Just follow it, and if you have some doubt, just put on the chat. Yes.
So for me, it is showing the missing destination file operand after home Madhav downloads.
Sorry.
Shall I share my screen?
Yeah, you can share it. That is because you are in your own directory.
It is in download section.
Yeah, it is in download. You have to extract it.
Extract. Then
I think you're missing the period after, like the destination is not being specified.
You have first extracted. It is not in your.
Yeah.
Yeah, extracted. So when this is done, you have to copy this. Go inside. So you have to copy. You have to extract this as well.
Shall I copy all these?
Yeah. First extract one of them. Extract K omega or K epsilon.
Next.
Let me wait. I'm not able to see your screen. Okay, you copy this to your download. Yeah, you can copy this here, or you can just copy it at your run also.
Okay. I'll try again.
Now go to your terminal. Okay, I'm gonna provide you some command. Okay, show me a terminal. See, I provided you a command that will mount your C drive, and then you can go to your download directory. But you have to replace that regni with your CPU name. Got it?
Okay. After CP, I have to.
No, first you have to go to the directory. Right now you are in the run directory. You have to go to the directory which contains your files, that is K epsilon and K omega. Or you can do this one thing. Erase this. Type erase all of them. Type explorer.exe space dot. This check the spelling. It is mistake. Explorer. You have space dot dot. Press enter. Okay, now copy those file here. I think it is already copied. You just have to paste it. Okay, now you can access this file from here, from your run thing only. You can use the terminal now.
Okay.
Now you can, if you do cd k epsilon, you will go inside k epsilon. Okay.
Okay.
Neha, can you present your screen? Okay, I think you have opened the wrong this thing, terminal root instead of Ubuntu 18.05. You might have installed multiple version of close this and go to the search bar. Close this thing. Once again, go to the close this thing. Close both of them. Go to the search bar. Type Ubuntu. So I see you have only one Ubuntu app. Okay. Click on it. Were you properly able to do other tutorials?
So yesterday I did, but not today.
Okay, what happened today?
Today, when I opened, it's opened like this only.
Okay. This is actually a root. This is a different WSL.
Okay.
You might have installed more than one WSL in your system.
No, sir. Only one.
Only one. Okay.
Yes.
So, are you able to carry out the tutorials in this?
No, sir.
Do you have OpenFOAM installed here?
Yes, I have installed it. Sir, if I'm writing this, now I
So
am
now you should be
showing.
able, yeah, okay. Now you should be able to use it, I think. I don't know.
But permanently, I'm not getting this.
Okay.
Yes. If I close it and again open it, I will be in root only.
Okay, it's okay. If you are able to use it like this, then you can.
Okay. Okay.
Sir, in a spoken tutorial, it is saying download code files. How can you download code files, sir?
Go to the website and on the right side at the bottom, click on code files. You just have to click on it and it will download it for you.
Hello, sir.
Yes.
Sir, after typing notepad.exe system blockness direct, it is coming no such file or directory is found.
So are you sure you have typed it correctly, the command, spelling and everything? You can present your screen.
Like this.
I think the M should be lowercase.
Okay.
Or you can just type like block and then hit tab and it will auto-complete it for you.
Yeah, if you want to do less spelling mistake, you can just use tab instead of typing the whole command. So if you press tab, it will complete it for you, Madhav.
And trying, but it is not happening. Like,
Let's see, the D is capital.
so how to copy a command, sir? Here, if I'm right clicking, it is not happening.
You can press the up arrow and I mean you can just press the up arrow button in your keyboard.
It is giving a sound, but nothing is coming.
The M is capital again. Yeah. Now press enter.
Maybe just like type ls system. Let's see what's in the.
Just type
Type
ls.
ls. Yeah. Yeah, you need to go into k epsilon and then cd k epsilon. Yeah, I
I
mean,
tried.
like you can stop presenting now. I think it's the same commands. It should work.
Those students who have completed the tutorials, can they raise their hand?
Hello.
Yes, Vekantesh.
Yes, sir. But I am typing the second code, sir, but it's showing no file cp dot
It's okay
downloaded.
because you have not copied it. Don't worry, I'll teach you how to do it now.
Okay, sir.
So even if you weren't able to complete the tutorial, don't worry. I'm going to show you guys how to do it now. You guys can just follow me. And if you have any question, just ask us in the chat. So I have downloaded the code file from the website. There are 3 code files. You don't need to do all of them, but if you have done it, then nice. Since the previous tutorial was on K omega, I'm gonna use just the K omega one to show you guys. So I have extracted this K omega, and now it is in my download folder. Okay, and this download folder is in my Windows. However, in my WSL, I am inside my WSL. Now, there is no download or any such thing in my WSL. So I have to physically go to this K omega directory if I want to simulate this. So for this, you have to use this command, cd space /mnt. mnt stands for mount. So what it will do, it will mount my C drive. So inside my C drive, which is here, and inside my users, and inside my PC name, that is readme, you will find that there is a download folder here, download folder. So you just have to give path of this C user readme download after the mount. So when I click on that, and when I give this command and press enter, just make sure that you might not have the name readme. Your PC might have its own name. And after entering this command, now I am in my download directory. Now if I do ls, there is bunch of thing in my download. So I don't want to see that. But I do know that I have already copied my K omega file in my download. So I'm just going to do cd and go to K small o, okay, K omega. So when I press enter, I'm inside my K omega file. Now if I do ls, I have 0, constant, and system in my K omega. So here, now what I'm gonna do is I'm gonna show you guys the block mystic. So notepad.exe system block mystic. So we have 2 block, and these are the vertices. And in each one of the block, we are using expansion ratio so that we get grading in our mesh that has a fine number of mesh near the wall. And we have, these are the boundaries, lower wall, upper wall, inlet and outlet. Since this is a 2D simulation, our front and back is kept empty, and we are not using merge patch pair. Merge patch pair is used to combine 2 different blocks if they doesn't share the same vertex. This is for advanced thing, but we are not using this here right now. And
Bhushan, just a minute. This is Joseph. You said just now, you said for 2D we are keeping, what is the condition in block mesh for 2D, since we are doing this in 2D?
Empty.
Which are faces we need to keep it empty?
The faces that is perpendicular to us. Like
Okay, fine. Thank you.
So let's go to the turbulence properties. So initially in turbulence properties, when you are doing laminar simulation, here there would be simulation type laminar, and there would not be anything. Even if there were these parameters, OpenFOAM would simply ignore this. Now we have RAS, and inside RAS we are using model K omega. Okay, I'm going to close this file. Now let's look at the 0. file. So inside 0, we have U for velocity, K, naught, and omega. So previously we used to provide boundary condition for only U and P. Now we need to provide one for K, naught, and omega as well. So let's open one of them. So here is the boundary condition for K, which stands for turbulent intensity. And this value you can calculate through empirical relation. This is more information is provided on our spoken tutorials. There is an additional reading material section. So if you go to the same website and scroll down, you will see code files, then script, then slides, and at the very bottom, you will see additional reading materials. From there, you can find out how we calculated this intensity thing. And outlet is kept 0 gradient. And we are providing some wall function in upper and lower wall. And as usual, front and back is kept empty because this is a 2D simulation. Now for knot, we are just using calculated. So based on the value of K, it will calculate the knot from that value. And on the wall, we are providing knot K wall function.
I'm sorry, could you tell me what is this NUT?
So
Not
this
understand.
this is a wall function that we are providing here.
No, this variable NUT, this folder. U
NUT
is for
stands
velocity.
for turbulence viscosity. Nu means nu, the viscosity, mu T. So
Okay.
in the while solving K omega, if you remember the lecture that was taught to you previously, so we are solving for omega, transport equation for omega, and transport equation for mu T. So it is just that parameter.
Okay, thanks.
And similarly for omega, again, we are using empirical relation to calculate this value. You can refer to the additional reading material. And in the previous lecture also, you were taught how to calculate this value, I think. And in outlet, we are giving 0 gradient, and we are using wall function in upper and lower wall. And front and back is kept empty. Okay, now I will run the simulation. First, I will do block mesh. This would mesh my geometry. Now I'm gonna do simple form. So my simulation is running. I'll just wait for some time for it to complete. Okay, my simulation has completed. So to view the result, first I'm going to create my dummy file, that is result.foam. And if I do explorer.exe this time it should open my download and K omega that is inside download because I'm in that directory. So here I am. I'll just click on this thing. And when I click and apply, you can see our geometry, and this is our pressure, but this is at time step 50. Okay. Now we'll go to time step 100. I would click on this thing. This is called rescale to data range. Whenever you have a simulation that has different ranges of values. So initially at 50, our range is different, and at 1000 the range minimum maximum value of 3 is different. So it will rescale my data according to the minimum and maximum of that time step. Now this is my pre-profile and this is my U profile. I'll just zoom in so that you can see it clearly. Here again, I think I have to do the rescale data to range, or it is already done. So let's view the profile. I'm going to click on this thing, plot over line, and click on y-axis, and then click on apply. So if you want to see U magnitude, this is the U magnitude. So you may have noticed that in case of laminar flow, our profile was parabolic, but now we don't have parabolic, we have something else. So when there is a turbulent flow, this is the profile that we get. And similarly, if you want to see P, this is the profile that we get for pressure. Now I'm actually viewing my profile at the middle. I'm just assuming that the flow is fully developed by middle. If you want to know more about where the flow is fully developed or not, in the spoken tutorial it was mentioned. So this is the end of the spoken tutorial. If you were not able to follow the spoken tutorial, this session will be provided to you. You can go back again and do the same time at your leisure. Meanwhile, if you have any question, you can type in the chat box or ask us.
Sir, in laminar and turbulence, which one is more realistic?
I don't understand what do you mean by realistic, because both
Like
of them are.
you saw that both having the different velocity profile, right?
Okay, it depends on your
So-
Reynolds number. So if your Reynolds number is very low, you don't need to carry out turbulence simulation. The laminar simulation is sufficient and it is accurate. But if your Reynolds number is very high, then your laminar simulation will not be accurate. In this case, you will need to do turbulent simulation.
So for very high Reynolds number, whether the simulation will stop in between or it will give some garbage value.
What do you mean by stop in between?
Like suppose we are simulating the simulation with very high Reynolds number,
Okay.
with laminar model, not the turbulence model.
So,
So in
okay.
that case, whether the laminar model will work or not.
In that case, depending on your problem, if your problem is very simple, it may work, but the value will be garbage. So you are just doing garbage in, garbage out. So if your problem is complex, then what happens is that you will not get convergence. Your simulation, the value of the residual, if you check, it will be very high, relatively higher than the one in laminar case. Someone is asking how to get pressure profile drop. Okay, I'm going to show it. Okay, I hope my screen is visible to everyone. Okay. So this is my pressure. So if I want to find out how my pressure changes gradually along the flow direction, I'm going to again click on plot over line and click on, but this time, instead of clicking on y-axis, I'm going to click on x-axis because my x-axis aligns with my flow direction. So if I click on x-axis and click on apply, I'm going to remove a bunch of useless parameters that I don't want to see because I only want to see pressure. Okay, so this is how my pressure drops. So at my inlet pressure is high, and you can see it is dropping somewhat linearly, and it reaches the value of 0. I think 0 is the pressure that we provided at the outlet. So based on that, it is actually calculating the pressure at inlet and other part in the domain. I hope that answers your question.
Hello, I have a question regarding the residuals like in the morning session.
Okay.
So you the maximum number of iterations in one of the demonstrations were put as 10. So
Yeah.
how do we fix that number like 10? Is it some trial and error or?
So yeah, it's a trial and error. By default, the maximum number of iteration is actually 1000. It was put 10 just only for the demonstration. So if you put 10 or 5, that is a very low value. So what happens is that your inner iteration will complete faster. The result that you will get will be a garbage out. in such case. So it was only for the purpose of demonstration. Generally, by default, it is at 1000, and 1000 is sufficient. So before 1000, it should converge. Does that answer your question?
Yeah, okay. Thank you. Thank you so much.
Okay, now I will close this session. Pioneer,
Yes, yes.
take over.
Yes, thanks a lot, Abhushan.